Hey guys, welcome to Code Decode. In this video, we will be looking into what is context window and why does it matter. Now, before coming and jumping to this context window, which is this part, I'll tell you that in the previous videos in the same playlist, we have covered a lot of stuff about LLMs, response generation, the difference of LLMs and RAGs and traditional backend APIs, the tokenization, everything we have covered. Now, I'm going to cover only those which are remaining in the phase 0 and then we will quickly move to the coding part of phase 1. So we'll quickly cover the 3 videos in next 3 videos, the remaining part of phase 0, then we will move to coding stuff. So let's get started and we should learn what is context window and why it matters to us. Now you'd ask me, why as a Java developer I should be interested into context windows. Now a biggest misconception is that we have unlimited memory whenever we compare and chat with the ChatGPT kind of stuff or Claude, because we think that a lot of stuff that we are giving as a context previously is always going to be sent as a input to our next query, and this happens also. So always when you query something, somehow your previous conversations are remembered and taken into consideration whenever you post a new query to ChatGPT or Claude. How does this happen? Because there is a memory where all of this basic important stuff is stored. But that doesn't mean that you have unlimited memory. If ChatGPT starts giving unlimited memory to all of its users, it will go out of space very soon. So you do not have unlimited memory. Unlike your database, which stores the information permanently, LLM only remembers which is included in the request. And that temporary memory is called as context window. And that is why you really need to understand that context window is important, because it is temporary memory. If you don't understand the context window, you will eventually run into issues like your model starts forgetting earlier messages. Your long conversations becomes expensive. Your context limit for the memory exceeds. And there's a poor response quality. Hey guys, so recently we have launched a very new course on Udemy, that is Spring Security 7. So now we have total of 2 courses. One on the Spring Security, second on the full stack application with all the deployment, pipelines, CI/CD, AWS Cloud, Kubernetes, everything. In Spring Security, we have covered authentication, authorization, filter chains, CRAN types, JWTs, OIDCs, SSO, CSRF, CORS, and very important, we have created here also a full stack project with a front end, back end, and security is implemented using Auth0 and Keycloak. Both of those authorization servers we have defined and created an end-to-end POC in this course. And the next course was on a full stack application where you understand microservices, Angular, JUnits, Docker, Kubernetes, AWS, EKS, RDS, Mongo Atlas, Jenkins, CI/CD, Argo CD, everything. So this makes a complete end-to-end project with front-end, back-end, and security implemented, deployed on the cloud also. Links of both of these courses will be given in the description below. Also, we will try to give some free coupons. Just let us know in the comment section for which course you would need the coupons. We will try to avail the coupons for the courses for free in the next month. Just for a small request, please leave your genuine, honest comments on these courses. That will help us create more such free courses or discounted courses for you guys. So just to quickly summarize, what is context window? A context window is a maximum amount of information an LLM can consider while generating a response. It's basically the maximum memory it can send to generate a response for you. Think of it as model's working memory. Everything in the model needs to answer your question must fit inside this context window. This includes your prompt. We have seen the prompt engineering in previous videos, right? So your user prompt, your system prompt, your previous conversations, RAG, everything should be included in your context window. Even the response should also be in the context window, because that response may become the request input for the next chat you do. So if this all information exceeds the model's context window or the temporary memory, then either you have to remove something or you will get into exceptions like there's a very long conversation with expensive stuff, or your memory has reached the limit. Now you would ask me, what is this temporary memory? So think of it like a RAM and not a hard disk where your database stores the data. The hard disk is a permanent memory, but RAM is the temporary memory. RAM only has what it is actively being used. Only that stuff is in memory. So as a backend developer, we already understand the difference between RAM and database. A database is a permanent storage for memory. but RAM only holds the data while it is being actively used. So all LLM context window is very similar to RAM and not to a permanent storage. So once your request is complete, the model forgets unless your application sends the information again. Now, this is a very good myth. We all think that since we have posted our few questions earlier with the chat GPT, for the next question you ask, all the previous conversations will be in memory for LLM or your chat GPT. Answer is no. It is a task of your application to retrieve the previous conversation, fetch only the important part, and then attach that as a attachment to the current user question. So your backend LLM, which is going to respond you, already has an input, which is your current question and your summary of previous conversations. So it is a task of your chat GPT application to zip, summarize, compress the previous information, attach it with your current request, and send it to LLMs, ChatGPT LLM models like 4.5, 5.6, and so on. And then your model, 5.6 model, respond you based on these two parameters, the current question and previous history. So who actually manages the memory? So most of us thinks the ChatGPT remembers everything that I have sent. In reality, that is not the case. The model does not remember anything. It is stateless. It's the application, that is ChatGPT UI or backend, is responsible for managing your conversations. For every new request, your backend typically retrieves the previous message, combine them with the latest input, and sends them everything to LLM. The simple LLM processes it, whether it receives what the simple LLM processes whatever it receives in the request. I'll tell you with an example. This is too much theory. So I'm going to log into ChatGPT with my Udemy account. Now suppose I start a conversation, say, hello, I am backend developer. I am working as XYZ role as senior contributor. So this is where your conversation starts getting saved. Now I'll start a new chat. What I'll do is tell me about myself. Now this is a new chat. But what this ChatGPT application as a front end and a chat application will do, it will tell me about myself as a question, take the history from this conversation, mix it together, and then start generating a response. So see, now inquiry about yourself, professional summary, overview, based on what you have shared with me so far. This is what the sharing of memory is. This is a temporary memory. Since recently I have searched about me that I am working as XYZ role developer, as a backend developer. Now it says, okay, so you are a backend developer. So I just here in the new chat says, tell me about myself. And everything that I have told him previously in the history is now given as an output also. So when I post another new chat and say, brief about me, what it will do, it will just not just send this question to ChatGPT, but also it will send the summary of whatever conversations we have done in previous two chats. And then as an output, it says, I am a backend developer as a senior contributor specializing in this, and XYZ stuff. So this is how a simple context memory or context window is created. And the task of giving this question and all the previous summary of previous conversations is a task of ChatGPT application to give it to ChatGPT model. So right now, I have the free model, great for everyday task. But I can easily upgrade and give it to a new model. So internally, who is responding you to this is a model, like 5.6 deep thinking model or kind of that stuff models. So it was that ChatGPT application and not the model who is responsible for retrieving the previous message. That application, ChatGPT application, here, this whole application, front end and back end, and not the model, LLM model, just the front end back end, is responsible to combine all these summary with the latest user input and then sends everything together to the LLM who is going to respond you like this. This response is coming from a LLM model, say ChatGPT 5.6 model. But that is not the core of the ChatGPT application. The core of ChatGPT application is a front end where you are able to interact with ChatGPT models. The backend which does all this bifurcation of your conversations and summarizing them and attaching it with each and every request you give to ChatGPT models. So LLM or models are simply the one who processes whatever it gets as an input. Who gives the best input is a task of the application, backend and frontend. So why can't we keep sending the entire conversation? Now imagine you have conversation like 15-20 conversation in a day. Now after hundreds of messages, sending the full conversation every time would consume lot of tokens. We have seen tokens in the previous video. Everything which is input, even the summary of the previous conversation are also consuming tokens. So you will end up having lots of tokens. You will end up increasing the API cost. You will slow down the response and eventually you will exceed the context memory limit, which is not good. So you cannot keep on sending it. Now, how the enterprise applications like ChatGPT handle this? So instead of sending everything, like what you see here, if there are 15 conversations, it will not send everything as it is. Rather, it will keep only the most recent messages and older messages are discarded. That is sliding window method of fetching which message to be summarized and sent. Conversation summary. Now, instead of sending all the complete conversation as it is, now instead of sending 200 messages, it will summarize into few sentences. For example, the conversation summary is customer ordered a laptop. It is delayed now. Consumer is preferring the refund if the delivery exceeds 5 days. This preserves the important context while not using the higher number of tokens. But even with the fewer tokens, your task is done. The third way how enterprise do is through RAG. Instead of storing everything in conversation, retrieve only relevant information. That too when needed. We will see it in phase 3. Now we will cover more about the chat memory with the phase 2 when we will learn more about Spring AI. But in this phase, as phase 0, we will focus only on the concept of context window being nothing but the simple memory, which is compared to RAM and not to the hard disk. And the implementation of this, like storing messages, trimming history, using the memory abstraction, everything will come when we will start coding with Spring AI.